Good morning friends. Today I would like to demonstrate an advanced implant prosthetic solution available in the laboratory. Look at this case. Whenever an implant is placed, especially in a misangled position, the available prosthetic solutions would be compromised. Why? Because when the implant is placed not favorably, usually you end up in placing an angled abutment and then a symmetrical restoration. But all the implant restoration should be passive and at the same time retrievable. So in a situation where the implant is positioned at a different angle than it is supposed to be, then the ideal treatment of choice would be to use a product called as a dynamic abutments in the form of dynamic tie base or direct to implant milling system. What this dynamic abutment would provide? These dynamic abutments, they come as a dynamic tie base and a screwdriver which has got a different configuration compared with the regular system. In a regular system, the screwdriver is more of cylindrical in nature and the screw can be accessed only in one direction. Whereas in dynamic abutments, the screwdriver is more of hexalobular shape with a screw axis in such a way that it can be accessed almost in 360 degrees from 0 to 30 degrees. So this dynamic tie base can be used in this manner. The dynamic tie base is screwed into position. On the top of it, a scan body is used in the laboratory for scanning this, and so that a milled prosthesis is generated. Commonly, the milled prosthesis can be in any form such as zirconia, titanium, DMLS for a chrome cobalt, PEEK or in the form of bio-HPP. So the milled prosthesis would have an axis which is more in a favorable direction, something like palatally. So in this case, when the implant axis is supposed to exit through the incisal edge, now it has moved palatally because of the screwdriver head and the dynamic abutments with the screw with a hexalobular shape. So it can be accessed and removed in this. So the dynamic tie base can be luted to this milled prosthesis with the help of any resin cement. Another advanced option for the same is where you can do a direct to implant milling system. How? In this case, if you closely look at it, the screw axis hole would have exited almost at the incisal edge or the labio-incisal surface. But due to this dynamic tie base and the screwdriver, it can be accessed from the palatal axis. The basic rationale behind it is it can be directly milled with the help of this special tool called as a dynamic milling tool. The dynamic milling tool will allow the axis to change and form a seating platform for the screwdriver to come and sit on this axis hole. So in a case where you don't want to use a dynamic tie base, still the angle can be changed in the form of a direct to implant milling restoration.